Hello students, in this video we will learn how to prove root 2 is irrational. Already we know that root 2 is an irrational number. We have seen the examples of rational and irrational numbers in the previous videos. Right? Now let us prove that root 2 is irrational. So to prove root 2 is irrational, first we need to assume that root 2 as an rational number. So first write the statement, let us assume root 2 as rational. Now we have assumed that root 2 is a rational number. Since we have assumed that root 2 is a rational number, root 2 can be written in form of p by q. Here p and q are co-prime and q should not be equal to 0. P and Q are co-prime. Co-prime means the factor of any two numbers should be equal to 1. Okay, then we call it as an co-prime and the Q is not equal to 0. Now shift this Q to the LHS and we can write root 2Q equals P. Now square on both sides. So both the LHS and RHS we need to square. So root 2Q whole square equals P square. Here square root and square get cancelled, will remain 2 and Q square. So 2Q square equals P square. Now if we transfer this 2 to RHS, it divides P square, right? So you write 2 divides P square, 2 divides P. So 2, if it is dividing the P square, then the same number 2 will divide the number P also. So after this, so this till here it's going to be first stage. Then after this, let, okay, instead of let you write substitute 2c in equation 1. Let us consider this as equation 1 and now substitute 2c. I am taking another constant, that is 2c, and I am substituting in equation 1. So our equation 1 is 2q square equals p square. So 2, sorry, let substitute p equals 2c. Okay, in place of p we are going to write 2c whole square. So 2q square equals 2 square is 4, c square, 4c square, and here we can cancel it out. 2 1s are 2 2s are. Q square equals 2c square. Now if we transfer this 2 to the LHS, it divides q square. 2 divides q square and 2 divides q. You can see here the number 2 is dividing p square and p, and after taking a constant in place of p, the 2 is dividing q square as well as 2 is dividing q. So in both the cases 2 is common, right? So 2 is common for both P and Q. Therefore, this conflict occurs due to our wrong assumption. Due to our wrong assumption. So here for P and Q we are getting 2 as a common factor, but what we have taken P and Q is a co-prime. Co-prime means two numbers should have a factor of 1 itself. So here apart from 1 we are getting 2 as a common factor. So this conflict occurs due to our wrong assumption. What we have assumed that we have assumed root 2 is rational. So since our assumption is wrong, so root 2 is an irrational number. So we have proved that root 2 is irrational number. So if you want to prove root 3, root 5, root 11, root 7, any number, okay, you can follow the same steps. So whenever we are proving root 3, so we have to, in place of 2, we need to replace it with 3 and we have to perform the same steps. Hope you have understood this concept. Thank you.